Okay, this is the first of a series of videos on the pre-calc exam debrief. I'll try to keep each of these to about 15 minutes. You should understand all the problems on the exam, especially the ones you got wrong. The second slide I have here shows some of the things we're looking for: ability to follow directions, memorize things, recognize patterns, solving equations, function notation. You can go back and look at this at your leisure. But let's jump into the warm-up problems. Here's the first warm-up problem. It says factor the cubic as a product of a linear expression and a quadratic expression. Start your answer with, we got to follow directions. Start your answer with x cubed plus 8, then an equal sign, and then the two factors. And we're told that there's a linear expression and a quadratic. So maybe we remember this. Hopefully we do. Here's an x plus 2, that's the linear, and an x squared minus 2x plus 4, that's the quadratic. If we were unsure, you know that you can always check factoring problems by multiplying them back out. So there's an x cubed, and a minus 2x squares, and a 4x's. And then distributing out the 2, we get plus 2x squared. Obviously, those are going to go out. Minus 4x, those are going to go out. And lastly, plus 8. So sure enough, by distributing, we see that we do have the correct product, x cubed plus 8. So we're sure that that is the right answer. Now, if we weren't sure, if we didn't check it, we may have noticed later on in the test, like in problem 37, there was this same question asked a different way. You had to find the correct factoring. Here it is down here. That's choice D. And there's a number of other options there that you could have chosen all wrong. Problem 38 has the same idea as well. Again, the same cubic, x cubed plus 8, this time divided by. And you see the quotient over here. What does this imply? What does this division imply? Well, you might want to think of an earlier or a simpler division. 3 goes into 21 7 times. And what does that imply? Well, that implies 3 times 7 is 21, right? So sure enough, this times this will equal that. And so there's your answer. And if that didn't pique your interest, maybe later on there was this question where you had to actually recognize the general pattern for sums and differences of cube factoring. And here it is over here. Hopefully you've seen this minus plus sign before. What that implies is that if you're choosing the top sign here, it's a sum of cubes, this is a sum, and this would be a difference. If you're choosing a difference of cubes, the minus sign, this would be a minus, and this would be the plus. At any rate, let's jump back into the warm-ups. The quadratic factor you wrote in warm-up 1 is called irreducible because it cannot be factored using real numbers. You'll see this next year in calculus. If we allow complex numbers, which we don't do in calculus at the high school level, it can be factored. The quadratic formula can be used to find solutions to quadratic equations. And the factors of quadratic expressions complete the quadratic formula. Oh, well, this is something we learned way back in Algebra 1. If ax squared plus bx plus c equals 0, then the x will be equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Make sure you bring the fraction bar all the way to here, and make sure you extend the radical past the product 4ac. The variable x here is important because if we had a quadratic expression or equation that was a t squared plus bt plus c is 0, then we would have to say t is equal to. Right? So yeah, make sure that you have the, I know a lot of people lost points because they just wrote the this part of the answer and they didn't have the x equals. But no, you need them both. And if that didn't quite catch you the first time, maybe you would have caught it the second time because you saw this problem later in the test. X squared plus bx plus c equals 0, and they all start off with x is equal to. So sure enough, you had to find the correct version, x is equal to. And lastly, the bonus, some people tried that. There was another version of the quadratic formula. If x squared plus bx plus c equals 0, then x equals. We might even try to play with that to see, and look, there's that minus plus sign again. Is that a valid version of the quadratic formula? Okay, let me pause this here. Okay, at any rate, let's look at warm-up number 3. The discriminant is the part of the quadratic formula under the radical sign. If you recall, that was the b squared minus 4ac. If we didn't know that, it told us, right, start your answer with b squared minus 4ac. And substitute in the values. This is our a value here. Our b is the -2, and the c is the constant. So we just plug those in there. -2 quantity squared minus 4 times 1 times 4. Once you do that, it says simplify, so not too hard. This is 4 minus 16, which is -12. And just as an aside, because the discriminant is negative, right, that tells us we have non-real solutions if we were to try to solve this equation, the x squared minus 2x plus 4 is equal to 0. If that's the equation we're trying to solve, then we would in fact have non-real solutions because the discriminant is negative. Okay, warm up number 4. The original cubic expression appears in this equation, and it can be solved by factoring. So how do you do that? You factor, then set each factor equal to 0, and then solve each of the simpler equations. So we'll follow the directions and do that. We have x cubed plus 8 is 0. It factors as x plus 2 times x squared minus 2x plus 4. We're using the zero product theorem here in algebra. It says that if you two quantities multiply to give you 0, one of them has to be 0. Either a is 0 or b is 0. And so the two quantities here are the factors, so we set those equal to 0. X plus 2 is equal to 0, and then solve that simpler equation and set this one equal to 0. But as we saw in the previous problem, this had no real solutions. So we're not going to have to bother about that. It does say use only real numbers. So yeah, the answer to that equation, or the solution, is x is equal to -2. The idea of setting factors equal to 0 is important. This was a problem later in the exam where you had to solve this equation, f of x is 0, and there's the f. And so we have x squared minus 6x plus 5 is equal to 0. Factors very nicely. X minus 5, x minus 6, or x minus 1 is 0. And so each factor, x minus 5 equals 0, x is 5. Or x minus 1 is equal to 0, x is 1. Two things to note here. Yes, you do set each factor equal to 0. That's important. But more importantly, the original product is equal to 0. So yeah, the fact that these two factors multiply to give 0 as a product allows us to set each factor equal to 0. If we had a similar problem, this was the next problem where you had the same function but now equal to 12, and we write x minus 5 times x minus 1 is equal to 12. It makes absolutely no sense. I hesitate to write this. X minus 5 is 12? Of course not. That's silly. In fact, there's lots and lots of numbers that multiply to give you 12. Right? It could be 3 and 4, or 1 and 12, or 144 and 1/12. So no, just because you have something factored, the key is this has got to be equal to 0. And lastly, you saw that idea of factoring and setting factors equal to 0 when you got to this problem on the exam, where you had to solve x cubed minus 2x, or is, let's see, x cubed is equal to minus 2x. And of course, the method of solution is to force it to be equal to 0 first. Add 2x to both sides. That's the key right there. Then factor x times x squared plus 2 is equal to 0. And then set each factor equal to 0. X is equal to 0, or x squared plus 2 is equal to 0, and that has non-real solutions, right? X squared is minus 2, non-real. Okay, so when we got to that, we got that one only. Okay, the last warm-up. We're solving this cubic equation by raising both sides of the equation to the same power. That's what the directions say. So we need to explicitly show that. Again, the question is not what is the answer. We know the answer is -2. That's not the problem. The problem is how do you solve it? So x cubed equals -8. We'll raise both sides to the reciprocal power. And the reciprocal of 3 is 1/3. So that would be a key step in here. I suppose you could indicate the cube root, and that would be the same thing. Some people did that. X cubed is -8. So the cube root of x cubed is equal to the cube root of -8. That would be okay. I sort of like this approach better. So we have x to the first is equal to, in fact, the cube root of -8. And then you should go ahead and solve that. So x is -2. You saw this same type of problem later in the exam as well, when you had to solve this power equation. And you do that by raising both sides to the reciprocal power. We have 3/2. We have 8. The reciprocal of 3/2 is 2/3. So we raise both sides to the 2/3. Now note, when you do this, sometimes you may have to introduce a plus or minus if you're taking a even root. We're taking a odd root, right? Odd root. And if you square both sides, oftentimes you will introduce extraneous solutions, so you have to check those. But here we're pretty much okay. So x to the first is equal to the cube root of 8 squared. And I'm a little ambiguous here. Did I mean the cube root of 8 squared like that? Or did I mean the cube root of 8 squared like that? And in point of fact, it doesn't matter. You get the same answer either way. This gives us 2 squared, or 4. And let me get my recording icon out of the way. If we go the other route and we square the 8 first, we get the cube root of 64, which is still 4. By the way, this is much easier because you use smaller numbers. Okay, so that was our warm-ups. And let me go ahead and stop this here. We're in about 13 minutes in. I'd like to keep these videos to about 15 minutes each. If you're unsure about any of the concepts here, please feel free to ask your teacher or a classmate as to what's going on. Little strict on grading this warm-up. I think there were very, very few people that got 5 points on these first 5 questions. Okay, stopping the video.